Hello everyone. Today I'll be solving this question number 31 from 2022 examination. So in this question, electric field is measured along the axis of a uniformly charged disk of radius 25 centimeter. So this is a charged disk of radius 25 centimeter, and they have measured electric field along this at some point due to this disk. Now there is some infinite plane having the same charge density. At a distance d, the field differs by 10% from that of an infinite plane having the same charge density. So there is some point d. At that point, the electric field due to these two surfaces that is given to us differs by 10%. So we need to find out the value of that d. So to find out the value of that d, first we should know the electric field at point P due to these surfaces, due to disk and also due to infinite charge, infinite plane. So to find out the electric field due to a disk, first I'm finding out the electric field due to this disk. So what I'll do, I'll take a ring of some radius r. Disk is made up of small rings. If you increase the area of these rings, they will make disk. So if you integrate this radius from this point to this point, from here to here, you will get the electric field due to disk. So first find out the electric field due to a ring. This is a ring with radius r. We need to find out the electric field at this point. So we will take these two elements here. Now electric field due to this element and electric field due to this element. This angle is theta, this angle is theta, this is theta, and this is also theta. So you can see here only cos component will contribute and sine component will cancel each other out, right? This is r dash. So E will be 2 dE cos theta, and E is equals to 2 dE is equals to dq 4 pi epsilon naught r square cos theta, right? dq is lambda dl because charge is distributed along ring, so it is lambda dl cos theta. Lambda is charge per unit length. Lambda is charge per unit length, line charge density. So it is lambda dl, and this is 4 pi epsilon naught r square, right? And you know cos theta is equals to base. Base is this upon hypotenuse, and this r. So it is d by r. So E is equals to 2 lambda dl d upon 4 pi epsilon naught d square r dash square 3 by 2. So it is equals to 2 lambda d pi r dash. This dl I have integrated, it is pi r because I have taken two diametrically opposite ends. So that is why the parameter is pi r dash. If suppose only one end will be would have been taken, then length integration will be 2 pi r. 2 pi r dash. 4 pi epsilon naught d square plus r dash square 3 by 2 E is equals to qd upon 4 pi epsilon naught d square r dash square 3 by 2. Okay. Now what we will do? So it is, yes, This Q has come because lambda is equals to charge per unit length, right? So Q is equals to lambda, length is perimeter 2 pi r dash. So that is why this 2 lambda pi r dash will become Q. So now we see here, this is due to the one ring. If we need to find out the electric field due to a disk, we have to integrate this E. So this E will become dE for disk. This E is E for ring, but if we need to find out the electric field due to a disk, this E will become dE and we will integrate it. So it will become d and charge will become dq 4 pi epsilon naught d square r dash square 3 by 2. Now again integrate it. Now in case of disk, sigma will come, surface charge density. So sigma is charge per unit area. So area is 2 pi r dash dr dash. Now put here, so it will be sigma 2 pi r dash dr dash, and this d 4 pi epsilon naught d square r dash square 3 by 2. So integrate this d e. So it will become E is equals to sigma d 2 pi 4 pi epsilon naught 0 to a r dash dr dash d square plus r dash square 3 by 2. Put r dash is equals to d tan theta. Dr dash will be d sec square theta d theta. Now here we have E is equals to sigma d 2 pi upon 4 pi epsilon naught d square tan theta sec square theta d theta d square plus d square tan square theta 3 by 2. Just simple mathematics. Sigma upon 2 pi epsilon naught, this 2 will cancel. Okay. Now d is here. D square tan theta sec square theta d theta. This will be dq. 1 plus tan square theta is sec square theta. Square square will cancel and it is sec cube theta. This cancel. This sec square will cancel this sec cube theta. This will also get cancelled. So E is equals to sigma upon 2 epsilon naught tan theta upon sec theta d theta. This is sigma upon 2 epsilon naught sin theta upon cos theta. This is 1 upon cos theta. So we get cos theta. Sorry, sin theta. It is sigma upon 2 epsilon naught minus cos theta. So now cos theta, put back the value of cos theta. Here we can see, cos theta is equals to d by r. So put back the value here. Sigma upon 2 epsilon naught. Cos theta, minus sign is here. Cos theta is d upon d square plus r dash square. And this is varying from 0 to a. So E is equals to minus sigma upon 2 epsilon naught d square plus a square. And then again, if you put 0 here, so this will become d under root d square plus 0 square. So this will cancel 1. So E is equals to sigma upon 2 epsilon naught 1 minus d under root d square plus a square. Okay. Now to find out the electric field due to a plane. So electric field we have found for disk. Now to find out electric field due to a infinitesimal plane carrying charge this. What we'll do, we will place a Gaussian surface like this passing through this, and we'll find out the electric field at these points due to this surface. So this electric field is along this direction, right? It is perpendicular to this plane. If we take this cylinder, so electric field is passing through this in this direction, and the area here is perpendicular. area having this direction. So the curved surface area and electric field are at right angle. So these will not contribute. Only these surfaces will contribute, circular surfaces. So electric field due to these surfaces will be E dot A plus E dot A, and due to curved surface it is 0. So it is Q enclosed upon epsilon naught. So 2EA is equals to Q enclosed. You know Q sigma is equals to charge upon area. So we can write Q is equals to sigma A upon epsilon naught. So it is A cancels. So E is equals to sigma upon 2 epsilon naught. So we know the electric field due to a disk and charge infinitesimal plane also. Sorry, sheet. So now in the question it is given the field differs by 10% from that of an infinite plane having the same charge density at distance d. So the difference is 10%. So that means the electric field at this point D due to a disk is 90% of plane. So the E disk is sigma upon 2 epsilon naught 1 minus d under root d square plus a square is equals to 9 by 10 sigma upon 2 epsilon naught. This will cancel. So it is 1 minus d under root d square plus a square is equals to 9 by 10. And d is given, d we need to find out, and a is given to us 25 centimeter radius. So it is 1 minus 9 by 10 is equals to d under root d square plus a square. This is 1 by 10 is equals to squaring both sides, d square plus a square. So it is d square plus a square is equals to 100 d square. So it is 99 d square is equals to a square. So d is equals to a upon root 99. It is 25 root 99. So the value will be if we take it as almost 100, so it will be 25 by 10. Under root of 100 is 10, so it is 2.5 centimeter approximately. So the distance d will be 2.5 centimeter approximately. Thank you.